Hi everyone, I'm teacher EJ. Welcome back to our YouTube channel. Today I would like to talk about a past year question from NMOS 2024, which is about the equal areal transformation. Let's have a look. So the diagram below shows a rectangle ABCD and a square DEFG side by side. So you can see that the rectangle ABCD and the square DEFG. So we say that the area of the rectangle is 150 cm square with the ratio of the length to the width being 3:2. And the area of square it is 64 cm square. And then we are asked to find the area of the shaded region in centimeter square. So everyone, let's try to see what's the information that we can get from this question. We know that the area of the rectangle is 150 cm square. And then we also know that the ratio of the length to the width is 3:2. So let's try to label it on our diagram. And finally, we are given that the area of square is 64 cm square. So everyone, when you have these three information, there will be one thing that is very easy for us to find, which is the length of the square. Since we are given with the area of the square, what is the formula to find area of the square? Oh, it is the side length times side length, which means that 64 is a multiplication of which two same number? Oh, so it is just 8 times 8. So we have found that the side length of the square is 8 cm. We are also given with the area of the rectangle, which is 150 cm square. Do we able to find what is the length and width? Oh, if we change the ratio into unit, let's say it is 3 unit and also 2 unit, we can actually try to cut our rectangle here into 6 identical square here. So everyone, what is the area of one small square? We just have to use 150 divided by 6, which is 25. So we know that the area of the square it is side length times side length. So for the area of 25, it will be equal to the multiplication of which same number? Oh, it is 5 times 5. So the side length of each small square it is just 5. So now we can find the length and width of the rectangle. For the width, we can just use 2 times 5, which is 10, and then for the length, which is just 3 times 5 and equal to 15. Alright, let's see if we can find the area of our shaded region, which is the triangle GEB. So, can we calculate the area of this shaded region directly? It seems impossible to do it. We are not given with any side length of this triangle GEB. Let's see if we can find another way to calculate it. Do we able to find what will be the total area of the whole figure? Oh, we can actually do that. So to find the total area, we just use 150, which is the area of the rectangle, plus 64, which is the area of the square. And it is equal to 214 cm square. Now, how about the unshaded region? Can we calculate it? Oh, we also can calculate the unshaded region. So we just have to use the whole area, we minus out the unshaded part to find our answer. So now, let's try to calculate it. We will start from the biggest triangle right here at the bottom. So we just have to use 10 times bracket 15 plus 8, then we divide by 2. For the triangle on the top, alright, on the top here, we just have to use 15 times 2, then divided by 2. And finally, the triangle on the right side here, we just have to use 8 times 8 divided by 2. So we just have to sum that out, which is equal to 162 cm square. So to find the area of the shaded region, we just have to use the total area, which is 214, then we minus out with the 162. And the answer will just be equal to 52 cm square. But everyone, actually for this question, there is also another method where many of the students will use to solve this question, which is by using the equal areal transformation. Previously, I have also recorded a video that explains more detail about the equal area transformation. You can try to check it out, alright? So now, let's try to apply the equal area transformation. We will need to find the two parallel lines that will enclose our shaded region, which is the triangle GEB. How do I find it then? Now, let's say we take one of the sides of the triangle GEB as a base, which is the line GE here. We know that this line it is the diagonal of the square. we will need to find another line that will pass through the vertex of the triangle, which is at the point B here, and it is parallel to it. I believe that some of you might just try to draw a line from B to D. But actually, this line is a diagonal of the rectangle, not a diagonal of the square. Therefore, it is not parallel to GE. So actually, what we can try to do is to construct a square ourselves. We can draw a line like this, and let's name it as the point M. Then, we'll get that the square with the side length, which is 10 cm, and the remaining part, it is 5 cm. Whoa! So to find the line parallel to GE, we just have to draw the diagonal of this square, which is the line BN. Oh, so now we say that the line GE is parallel to the line BN. So in this case, we can try to move the vertex of the triangle from point B along the parallel line to point M. Oh, we will now get a new triangle GEM. We say that the area of the triangle GEB is equal to the triangle GEM. So now guys, to find the area of the shaded region, we can just directly use the formula for triangle, which is bracket 5 plus 8 times 8 divided by 2. And we will get that is also equal to 52 cm squared. And this is our final answer, right? So now, let's summarize what we learned in this question. So to find the area of the shaded region, the first method that we use is to find the whole area and then we minus out the unshaded area. Then we also use the equilateral transformation method to solve this question. So for triangle between a parallel line, we can try to move the vertex of the triangle along the line and the area will remain the same. So everyone, although many of you will like to use the equilateral transformation, but sometimes there might be some question that you are not able to do so, and then you just give it up. So you cannot do that. What you should do is, you should try to use other methods. For example, you can use the formula, or you can try to use whole area minus out the unshaded area, right? So now you can try to do this practice question and you can leave your answer at the comment section below. So you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.